All right, mathletes, here's 2.2 graphs of functions. So we've talked about our vertical line test. Vertical line test is a set of points in the xy plane is the graph of a function if and only if every vertical line intersects the graph in at most one point. So when we're talking about graphs and identifying functions, we can do the vertical line test. In other words, we've talked about no single input has more than one output. As we looked at models before, we cannot have one single input going to two different outputs. That is not a function. Okay, be careful with this. It is okay if we have two inputs that go to a single output, meaning two inputs have the same solution. That is okay. But we can't have a single input giving two different outputs, two different answers. This is okay for a function. This is not. All right, so let's look at some examples of some graphs. Okay, so here we're going to determine whether they're a function, and we're also going to talk about domain and range, intercepts, and symmetry. So f of x equals x squared plus 3. We have a quadratic with a vertical shift up 3. So if I operate and draw a vertical line and drag it across my graph, nowhere does it intersect more than once. So yes, it is a function. So the domain of this function is going to be, well, any number I can square and add 3 to. This graph is going to go up and to the right to infinity and to the left and up to infinity. So our domain is for all real x's. Now our range. So range, a good thing with a parabola, you want to think about your vertex. Because at your vertex, you're going to have, if it's concave up, it's going to be all the points up, and concave down, it's going to be all the points down. So knowing your vertex is going to be important here. So here we can see our vertex is 0, 3. So that means from 3 up, I'm going to get every single y value. So for all real y's such that y is greater than or equal to 3, because 3 being the vertex is going to be a solution there. So next, my intercepts. So notice if I let y equal 0 here, or f of x, okay, I'm going to get no solutions possible because I'll get x squared is equal to negative 3. Well, nothing squared can be negative, hence we have no x-intercepts. Okay, so my y-intercepts, so that's when x is equal to 0 for my y-intercepts. So when x is equal to 0, I get y is equal to 0 squared plus 3. So y is equal to 3 for my y-intercepts. Okay, and I can see that right there with the vertex. And part C, talking about symmetry. Well, my symmetry here is going to be along vertical, and it's going to be along my y-axis. Okay, so for our next example here, we have f of x is equal to the square root of x plus 6. Okay, so for this, I'm going to a square root is always kind of good to see. It's the top half of a sideways parabola. Okay, if we wanted the bottom half here, we'd need the negative there, but we don't have it on here. So we understand that this function is going to go to the right and up forever, and it has an endpoint right here because our domain is going to be restricted. So our domain is restricted because we can't have square roots and negative under the square root. So we know that x plus 6 has to be greater than or equal to 0. So x has to be greater than or equal to negative 6. So our domain is for all real x's such that x is greater than or equal to -6. And I can see that from here. We're going to go on forever, starting at x and -6, and we're going to go right forever. So our range, big thing with square roots, we know that this, it can't be greater than 0, because a square root isn't going to give, a principal root isn't going to give rise to something greater than 0. It can be equal to 0, because we can let x be -6. We can get a value of 6. Square root of 0 is 0. So our range is for all real y's such that my y is going to be greater than or equal to 0. Okay. So our next piece here is our intercepts. Well, our intercepts, I can kind of see that there's 2 here. So to find my y-intercept, I let x be equal to 0, and I get f of x, or y, is equal to the square root of 0 plus 6. So y is equal to the square root of 6 is my intercept there for my y-intercept. Now for my x-intercept, I'm going to let y be equal to 0. And when y is equal to 0, I get 0 is equal to the square root of x plus 6. If I square both sides, I'm going to get 0 squared is 0 equals x plus 6. Then I get -6 is equal to x. So then I can see I have my 2 intercepts here. My third piece is symmetry. I don't have any x or y symmetry. I can't draw a line vertical here. It's not the same. It's not the same here. And around the origin is another way of saying it has 180-degree rotational symmetry. Well, if I rotate this 180 degrees, it's not going to have that symmetry. So no symmetry for this one. Okay, let's look at a couple more examples here. So for w of x equals 3 over x. So notice we can still have function that it doesn't have to be an f there. So this notation we always assume is still just functional notation. We just call this function w of x. So with this rational function, my first part is my domain. Well, I don't want this to be 0. Well, it's nice because I don't have any, it's just a simple x, so I know my domain is for all real x's such that x cannot be equal to 0. Okay, my range. So my range, because x can't be equal to 0, I can't have this entire function be equal to 0. So notice on my graph, I don't have a y value. I have an asymptote here where my y value cannot be 0 because I can't, there's no way that I can let this be equal to 0 function. So my range is for all real y's such that y can't be equal to 0. Okay, so that's A. B, we're looking at intercepts. Well, if I let y be equal to 0, so my x-intercepts, I let y be equal to 0. So I can always think of w, my function, being equal to y. So then y, letting y be equal to 0, I'm going to get 0 is equal to 3 over x. Multiply x by both sides, and I'm going to get, and then this drops out because I get 0 times x is 0 is equal to 3. Well, that's not true, so there is no y x-intercepts. And I can see on my graph that it doesn't cross my x-axis. Same thing is going to happen with if I let y be equal to 0. Well, I can't, or For my y-intercept, I would let x equal be 0. And I can't divide by 0. So no intercepts. Okay. Third piece, symmetry. So if I look at this graph here, I don't have any x or y symmetry. I can't reflect it across the x-axis. I can't reflect it across the y-axis. But note that if I do rotate this 180 degrees, it is the same graph. So that's what we call, it has symmetry about the origin. Okay, so part 4. So we have the square root function and we have a plus or minus. Okay, well here we're going to notice that this doesn't pass our vertical line test. As we come across, we see we get multiple solutions here. It looks like a circle here. It's an equation of a circle. So it's not a function. So it does not pass the vertical line test. We can still go through and define our domain and range. So our domain is, so if I kind of simplify this, let f of x equal y and square both sides, I get y squared is equal to 81 minus x squared, and I get x squared plus y squared equals 81. It's just an equation of a circle written in the form of a function so that you can plug it into your calculator there. So the thing to remember with this is, so our domain is going to be for all real x's such that x has to be, so 81, we know this radius is 9. So my x's have to be between, so I can do a compound inequality, 9. It can be equal to 9 to x. It has to be less than 9 though. Okay, so if I did interval notation, it'd be -9 to 9. Okay, so that's my domain. My range is going to be very similar because it is a circle centered around the origin. And I'm just going to do interval notation, -9 to 9. Okay, the symmetry, all three of them work. It's symmetric about the x, symmetric about the y, and it has rotational symmetry. Okay, next piece. So even and odd functions. We're going to define even and odd functions. Even functions have symmetry about the y-axis. In other words, their values when x's are negative are the same when x's are positive. So parabolas is our classic even function. Notice if we look at our graph of this function, we can see there's symmetry about the y-axis. And then also our absolute value function, 8 minus x, we can see that there's symmetry about the y-axis. So this is what we determine is even type functions. Okay, so even type functions, again, classic parabola. And then we also have absolute value functions. We are going to call those even functions because they have this line of symmetry here. Okay, our second family of functions are going to be odd functions. Odd functions are going to have that symmetry about the origin, so meaning it has rotational symmetry. So if we look at these graphs here, you can see x cubed minus x has that rotational symmetry. If I rotated this 180 degrees, it would be the same exact graph. So that has symmetry about the origin. We can look at this rational expression. And we can see if we rotated this graph about the origin, we'd also have that symmetry. So these are what we consider odd functions. Okay, so our cube root function looks something like this. And then this one had asymptotes here and there, and then something like that. All right, so those are our add odd functions if you had that symmetry about the origin. That concludes our notes for tonight. Please make sure you highlight questions and bring them to class tomorrow.